Hello students and welcome to 11th standard physics, first PUC physics. In this video lecture, let us cover equations of motion. Here, equations of motion refers to equations of accelerated motion. So those equations are V equal to U plus AT, S equal to ut plus half at square, and v square equal to u square plus 2as, where u stands for initial velocity, v is final velocity, t is time duration, time interval, and s is displacement. Here common mistake is yes, sometimes people will take it as distance, but please bear in mind S stands for displacement. Okay, since it is accelerated motion A, suppose a vehicle is moving at time t equal to 0, it has 2 meter per second, means this 2 meter per second is the initial velocity denoted by u. So velocity at time t 0 is called initial velocity. After 4 seconds, t equal to 4 second, velocity of the body is 8 meter per second. So at this instant, velocity is 8 meter per second, means this velocity is final velocity. Velocity increases means it should be accelerated motion. So under acceleration A, body attains velocity 8 meter per second. So acceleration we don't know, some value. Okay, so such problems are solved using these three equations, and these three equations are called equations of linear motion, equations of one-dimensional motion, or simply equations of motion. Okay, since it involves initial velocity, acceleration, and time, the velocity time graph of this is velocity time graph, initial velocity u, so this is initial velocity, because at time t equal to 0, body has velocity that is called initial velocity. It should be accelerated motion, therefore this represents accelerated motion. At time t, velocity is v, so this velocity is v. This is velocity axis, time axis, and this velocity is v. So v is velocity at time t, also called instantaneous velocity. So using this diagram, we have to derive these three equations. We can derive these three equations using calculus method also, but in the initial stage, let us derive these three equations using velocity time graph. Y-axis, velocity axis, time axis, this is time, velocity, with initial velocity means somewhere from this point. I should represent accelerated motion. So this represents acceleration. So AB represents velocity time graph. OA is initial velocity u. So this is initial velocity. This is final velocity. time t. Let this point be C. So OC represents t, and velocity at t is this, which is final velocity. This is reference line. Let this point be D. If this represents final velocity V, then this height represents final velocity minus initial velocity, that is V minus U. V minus U. So BD is V minus U. BC is final velocity V. So using this graph, we should derive equations of motion. Now let me write few statements. Consider a body moving with uniform acceleration with initial velocity u. Let AB be the velocity time curve. Here OA represents initial velocity, OC is the time, BC is the final velocity at time t. Therefore BD is the change in velocity. Now first equation, to derive V equal to U plus AT. Okay. So acceleration. Slope of this graph represents acceleration. Slope of AB gives acceleration. So acceleration A equal to slope of AB, and slope means y component by x component. It is BD by AD. It is always y component by x component. You should identify a triangle, right angle triangle, and in that right angle triangle you should consider tangent of this angle. Okay, that gives slope. Therefore slope of AB. Slope of AB is BD by AD. BD is V minus U. AD is nothing but OC, which is nothing but T. Or rearrange AT equal to V minus U, or V equal to U plus AT. This is first equation. For time being, please follow this. In vector form, write V equal to U plus AT. After that, draw arrow. This arrow is only for vectors. Next chapter you are going to study about vectors. Okay, for time being, please write this, copy this. V, this is U, velocity vector, initial velocity vector, acceleration is a vector. t, time, is a scalar quantity. Don't write arrow to this. So this is the vector form of v equal to u plus at. Next equation, s equal to ut plus half at square. So displacement, area under velocity time curve gives displacement. Velocity is meter per second. Area means area, product of unit of velocity and time. Unit of velocity is meter per second. Unit of time is second. So if you simplify, you'll get meter, which is unit of displacement. Therefore, area under velocity time curve gives displacement, and we are making use of this fact. Area under velocity time curve gives displacement. So displacement equal to area of the trapezium. So it's a trapezium, right? A, B, C, O. Because these two sides are parallel to each other. It's a four-sided diagram. So it's a trapezium. And area of trapezium is half into distance between parallel sides, that is this distance, OC, into sum of the parallel sides, OA plus CB, equal to half OC. OC is time, therefore T, OC by 2, T by 2. OA is initial velocity, plus CB is final velocity, V. T by 2 U plus final velocity, just now we derived, V is U plus AT. U plus AT equal to T by 2 2U plus AT equal to, multiply T by 2 into 2U, 2 get cancels, UT plus T by 2 into AT, half T square, half A T square. This is displacement. This is second equation. In vector form, S equal to UT plus half AT square. S vector, initial velocity is vector, acceleration is vector. You should draw arrow above S, above U and above A. Okay. So this is the vector form. Next, third equation. V square equal to U square plus 2AS. We should derive this expression. Consider V equal to U plus AT. There is V square, therefore square this. V square equal to U plus AT whole square. V square equal to, it is of the form A plus B whole square. So U square plus A square T square, A square plus B square plus 2AB. A is U, B is AT. There is U square, there is U square, retain U square plus take 2a common factor. From this 2a common factor means ut. There is no 2 term here. If you take 2 outside means it becomes half. 1a is outside, therefore remaining is a t square. So what is ut plus half a t square? Yes, v square u square plus 2a s. So this is the third equation. In vector form, v square is a scalar, u square is also a scalar, plus 2 into a, vector a, you should draw dot here, and vector s. So this is the vector form of v square equal to u square plus 2a s. Students, copy all the steps from this chapter. This is the important question for 5 marks. With velocity time graph, you have to derive all the 3 equations. Okay. To be on safer side, please write vector forms of the equation. Let us solve few basic problems. Based on the concepts and equations, let us solve few basic problems. Okay. A car covers first half of the distance between 2 places at 20 km per hour and the rest at 40 km per hour. Calculate the average speed. Try to draw simple diagrams. If this is initial position and this is the final position, destination, car covers half of the distance. Half means half. Let half of the distance be x, which is unknown. This half of the distance is covered with 20 km per hour. So it is 20 kmph. And the rest at 40. So remaining is also same distance, x, covered at 40 km per hour. Okay. Calculate the average speed. Don't forget to write the equation or the formula. Without formula, if you solve the problem, average speed denoted by v average, use angular bracket, equal to total distance by total time taken. This is how average velocity or average speed is defined. If this is distance, speed. If this is displacement, then this is average velocity. Okay. Total distance means x plus x is the total distance. X, other distance is also x. Now we have to find total time taken. Speed equal to distance by time, or time equal to distance by speed. Distance by speed. Distance by speed. X by 20. Therefore, first time interval is x by 20. Next time interval is x by 40. T2 is x by 40. Distance by speed gives time. Therefore, total time is T1 plus T2. T1 plus T2. X plus x is 2x. Denominator T1 is x by 20 plus x by 40. This is average speed equal to, numerator is 2x, denominator, let me take x by 20 common factor. X by 20, remaining is 1 plus x is outside, 20 is outside, therefore 1 by 2. 2x by x by 20 1 plus 1 by 2 is 3 by 2. X get cancels. 2 goes to numerator. 2 into 2 is 4. This 2 also goes to numerator. 2 by 3. 20. So it is 80 by 3. 80 by 3. Therefore, average speed is 80 by 3 is 26.66. Therefore, 67 kilometer per hour. Unit is kilometer per hour. A vehicle travels from A to B at 10 km per hour and B to A. This is A. This is B. A to B at 10 km per hour, to and fro. B to A at 40 km per hour. Calculate the average speed. Average speed equal to total distance traveled by total time taken. Let distance between A and B be x, unknown. Therefore, total distance is x. From B to A, again x. Total time is t1 plus t2. Speed equal to distance by time, or time equal to distance by speed. Therefore, t1 is distance by speed, x by 10. X by 10, and t2 is x by 40. B to A is also same distance, therefore x by 40. Numerator is 2x. t1 is x by 10 plus x by 40. Denominator, take x by 10 common factor. Remaining is 1 plus 1 by 4. X by 10. 1 plus 1 by 4 is 5 by 4. X get cancels. 10 goes to numerator. 20 by 5 by 4. 4 also goes to numerator. 4 by 5. 5 1, 5 4, 4 4, 16. So 16 kilometer per hour. This is the average speed. And this is the common mistake. 10 40, 10 plus 40 by 2. Because speed has two physical quantities, distance and time. That is why it is not appropriate to consider this method. A car is traveling at a speed of 54 km per hour. So this is initial velocity. So initial velocity is 54 km per hour. So this is kilometer per hour. Convert this to meter per second. Initial velocity is 54 kilometer per hour equal to convert kilometer per hour to meter per second, multiplied by 5 by 18. 18 1, 18 3, 5 3, 15. 15 meter per second. Okay. Remember this method. From kilometer per hour to meter per second multiplied by 5 by 18. Time taken to cover 2 km. So first one, speed is 15 meter per second. Time taken to cover, distance is 2 km. 2 10 power 3, 2000 meter. Isn't it? So it is uniform velocity or uniform speed. Therefore, V equal to S by T, or T equal to S by V. S is 2000 by speed is 15. Give 1 0 to this, make it 20 by 15 into 10 power 2. 4 by 3, 5 3, 5 4. 4 by 3 is 1.33 into 10 power 2 or 133 second. This is time. Second, the distance traveled in 5 minutes. B, distance S, time in 5 minutes. 5 minute, 1 minute is 60 seconds equal to 300 second. ST, V equal to displacement by time. Therefore, S equal to speed into time. Speed is 15, time is 300. 4500 meter. 15 3 45 is 0000. So this is the displacement or distance traveled. Starting from rest, car is traveling with an acceleration of 2 meter per second square. So initial velocity is 0, acceleration is 2 meter per second square. The distance traveled in 10 seconds. First one, distance traveled S question mark in 10 seconds. T 10 second. ST. Remember the equations of motion. V S T. ST means ut plus half at square. S equal to ut plus half at square. Vt means V equal to u plus at. Vs means V square equal to u square plus 2as. Therefore, we have to use this ST. S equal to ut plus half a t square. Initial velocity is 0 plus half, acceleration is 2, time square 10 second square, 10 square. 2 get cancels, 10 square is 100. So displacement is 100 meter. B. Velocity at the end of 20 seconds. V question mark T 20 second. Vt. V equal to u plus at. Initial velocity is 0. It is mentioned. Acceleration is 2. Time is 20. Equal to 40 meter per second. Time taken to cover the distance. Time taken to cover a distance of 150 meter. C. Distance of 150 meter. Time question mark. ST. S equal to ut plus half at square. 150. Initial velocity is 0 plus half, acceleration is 2, t square. 2 get cancels. So t square equal to 150 or t equal to plus or minus root of 150. Plus or minus root of 150 is 12.25 second. So t equal to 12.25 second. Fourth, velocity at the end of 50 meter. Velocity question mark, displacement 50 meter. Vs. V square equal to u square plus 2as. Initial velocity is 0. 2, acceleration is 2, displacement is 50. This is v square or v equal to 22445 100. 50 into 2, 100 into 2, 200. So v square equal to 200, or v equal to plus or minus root of 200 is 100 into 2, 10 root 2 meter per second. Final velocity. You can also write this as root 2 is 1.41. 1.41 times 10 is 1.41, 14.1 meter per second. This is v.